Welcome back. We'd like to create some components for our actor in C++, but it's important to understand a few concepts first. When we create a class in Unreal Engine, such as our item class, which is derived from the actor class, Unreal Engine creates a class default object, or CDO, based on that class. The class default object is a master copy of the object, contained in Unreal Engine's reflection system. It's created when the engine starts up. Compiling our code essentially kicks off the generation of this as well. It holds the default values that can be accessed by the reflection system to initialize the properties in Blueprint objects created in the world based on our class. When the engine initializes, it creates these class default objects for each class. Then it executes the constructors of each class, setting their default values. And this is particularly important for blueprints. Blueprints get their default values initialized by the engine, and that information is retrieved from the class default object. All of this happens under the hood for us, so we can make games and never even know this process is occurring. It is important to know about this process, however, because since the constructor for a given class is executed this early in the game engine process, it's usually too early to do certain things in a class's constructor. If we want to do something at the beginning of the game and be sure that all objects in the game are initialized, we must do so in begin play and not in an object's constructor. For example, you might have a class called Bomb that explodes at the very beginning of the game. Now, you might want it to see which actors are close to it and then cause damage to them. Well, you wouldn't want to do this in the bomb's constructor. That's too early, and not all actors in the world are fully initialized yet. The engine hasn't yet created their class default objects to initialize all of these actors with their default values. For this type of functionality, you must use begin play instead because by then, all actors are fully initialized. Now, the reason we're bringing up this class default object is because a similar process happens for components. Let's say we have our item class, and we add a component called item mesh. Well, to add this component, we have to create a default subobject for this component. The default subobject behaves much like a class default object, only it's for the component itself, and it contains all the default properties for that subobject. In Unreal Engine, components are subobjects of their owning actor, remember? Now, when we create a default subobject, we have to supply a couple of pieces of information. For one, we need to specify the object type of our subobject, for example, useStaticMeshComponent. And we also need to provide an internal name. This is a name that's different from the actual variable name itself, and it's used by Unreal Engine for various purposes, mainly keeping track of different objects. To create a default subobject, we use a template function. Remember, we just learned about template functions. They're just functions that also have angle brackets that receive a type as a parameter. So they're very versatile, and create default subobject can take different component types. So in the angle brackets, we provide the component's type, such as useStaticMeshComponent. And in the parentheses, we provide the name for the object. This is that internal name. We pass it in as a string. And as we've learned previously, it's a good idea to wrap our string literals in the text macro to ensure that they're in the Unicode format. So this is how we create the default subobject for a new component. Now, create default subobject returns the address of the newly created subobject, so we can store that in a pointer. A function that creates an object for us like this is known as a factory function. A factory is simply a function that constructs an object for us. So in C++, you might be used to using the new keyword to construct a new instance of an object and store the address of that object in a pointer. In Unreal Engine, we rarely ever use the new keyword, as the engine has these factory functions that construct the object for us and perform lots of internal bookkeeping, such as registering that object so the engine knows about it. So now that we understand that to create a new component in C++, we have to create a default subobject, let's get some practice creating a component for our item class. So we're back here in item.h, and I'd like to add a new component. Now, we're going to go down to the private section and add the component here. But before we do all this, I'd like to clean up this class, as we have lots of different things that we've added here strictly for educational purposes. So let's go to item.cpp and remove some things. Now, I'd like to keep our transformed sine and cosine functions, as these can be useful, and we may want sinusoidal behavior for our item class. But we're not going to need to draw our debug sphere, debug vector, and debug point, as we're about to add a component that we'll be able to see in the world. So I'm going to remove these lines of code, but I'm going to keep that running time just in case we'd like some sinusoidal behavior in the future. Now for creating our new component. Let's go back to item.h. And down here in the private section, let's add a new variable. Now, I'd like this variable to be a pointer of type uStaticMeshComponent. And I'm going to call this itemMesh. So we have a static mesh component variable, but this doesn't actually create a new static mesh component. All it does is create an empty pointer. Now, we're going to want this pointer exposed to the reflection system and also to blueprints. So we can give it a U property. And when we create a new component and store its address in this pointer, we'll have our subobject existing on our actor, and Unreal Engine tends to garbage collect things. It goes through and looks for objects in the world and sees if we have any pointers pointing to it, and if not, it'll simply delete those objects. Adding U property will mark this variable to participate in the reflection system, and so Unreal Engine will know that this particular pointer points to a given object, and it'll recognize that that object is still being used and will not be garbage collected. Now, just adding U property is not going to expose this to blueprints. We have to use one of our macro specifiers to do that, such as Visible Anywhere. When it comes to static mesh components, we use Visible Anywhere to expose it to the blueprint and see its properties. So now that we have an item mesh pointer, we need to actually construct a new static mesh component subobject. So we'll go to item.cpp, and the place to do this is our actor's constructor. So here in the constructor, we're going to create a new static mesh component. And to do that, we have to create the default subobject. So here's how we do it. We call the function createDefaultSubobject. And this is a template function, which means we need to provide the type for the subobject here in the angle brackets. And the type we'd like to create is uStaticMeshComponent. And in the parentheses, we add the internal name given to this component. So we'll use a text macro, and we'll call this itemMeshComponent. And there's our semicolon at the end there. So this creates the default subobject, but we mentioned earlier that this function returns a pointer to the newly created object. So we need to store that in our itemMesh pointer variable. So that's what we're going to do. We're going to say itemMesh, and we'll use the assignment operator to store the address returned by this factory function in our itemMesh variable. Now, we also mentioned that the root component can be reassigned to a different scene component. itemMesh is a uStaticMesh component which derives from scene component, which means we can take our actor's inherited root component variable and reassign it to itemMesh. And just like in blueprints, that default scene root that our root component pointer variable stored the address of is going to be deleted automatically. And that's because the garbage collection system will see that root component no longer points to it. And since it won't have any pointers pointing to it, it'll be garbage collected and deleted. And now our root component pointer points to our newly created itemMesh subobject. So let's see how this works by hitting Save All and hopping back into the editor. And we'll go ahead and hot reload. So now that we've finished hot reloading, let's go back into BP item. And now take a look at what we see here. Now we see our item mesh, but for some reason there's still this default scene root hanging around. So something hasn't quite updated properly. Now I'm going to close out of the editor and properly compile from Visual Studio and launch the editor at the same time with Control F5. Now I'm going to let Unreal Engine reopen my BP item blueprint. And now things look better. So if something doesn't look right after you hot reloaded, just close out of the editor and start it back up, and things should usually be refreshed properly. Now, if we click in the viewport, we don't see anything, and that's because our item mesh is a static mesh component which has a static mesh variable, but it's by default set to none. Now, if we wanted to, there's a way to hard code the static mesh directly in C++, but this is not good practice. It's usually good practice to create the component in C++ and set its static mesh property here in the blueprint. This makes this a lot more versatile, as we could create multiple item blueprints and set their static meshes separately in each blueprint. So we can set the static mesh variable here. Let's click the dropdown and choose a static mesh. I'm going to choose shape underscore quad pyramid. And now our BP item has a static mesh component with its static mesh set. Now let's take a look at the Components tab again. We have item mesh. We called it item mesh, one word, without a space, as you can't have a space in C++ variable names, right? But in the editor, Unreal Engine sees that we had two words, as mesh and item are both capitalized, so it does us the courtesy of placing a space there to make it a little bit more readable on the blueprint side. Now notice again that we have item mesh component in parentheses. This is that internal name that we provided, wrapped in a text macro, in the parentheses for create default subobject. So we can see that internal name there. Now we made this item mesh variable visible anywhere. That's because if we made it edit anywhere, that would mean that we could simply change the pointer value, which is an address, here in the editor, and that doesn't really make sense for a scene component. We don't typically make our scene components edit anywhere. We make them visible anywhere. And the scene components themselves have their own properties in the details panel, which can be changed. As we've seen, we just changed its static mesh variable. Now notice in the transform section, we have a scale, and we did mention that scene components have a full transform containing location, rotation, and scale. But as we've seen, if this particular component is the root component, we cannot change its location, or its rotation for that matter, here in the blueprint, as its transform behaves as the actor's overall world transform. So to change its location, we would only be able to do that on an instance of the actor in the world. Now here's one of the BP items. If we select BP item 2 in the outliner and press F, we'll see that that other item is also here at the same location. So they reset back to the origin of the world, but we can go ahead and move those if we like. So let's move them out to the side here and press play. And we see that they're still moving around in circles. And that's because, of course, we're using those blueprint pure functions we created, transform, sine, and cosine, and calling add actor world offset and event tick. Now this was a nice trick, using sine and cosine to change the x and y location to give it circular movement, but I think I'd like the bobbing behavior that we got by using transformed sine on the z location. So I held Alt and clicked these output pins to disconnect them, and I'm just going to use transformed sine on the z location and go ahead and delete my transformed cosine function and compile and save, and now I can see that they're bobbing up and down. So this shows us how we can create new components from C++. Going back into Visual Studio to recap, what we had to do was create a pointer to the component using the given component type, and to expose it to the editor so we could change its static mesh, we gave it visible anywhere. And in the CPP file, we constructed this object by creating the default subobject for it here in the constructor, and then we reassigned our root component to store the address of our newly created item mesh, so the default scene root that all actors get by default is deleted, and instead our root component is set to our item mesh static mesh component. So now we know how to create new components in C++. Excellent job! I'll see you in the next video.